Hi all, let's now try to solve this question. So let's just see what this question is saying. Let x and y be independent uniform random variable on 0, 1, which means that x and y are continuous independent uniform random variables in 0, 1. Then they have defined a new random variable w, which is maximum of x comma y. See, first you need to understand that what is this continuous uniform random variable. See, I say that let's suppose I'm defining a continuous random variable, uniform random variable in between a and b. I say that here the probability density function is constant, which means what? That if you have any value between a and b, I mean the probability density function is basically the same value between a and b. Let's suppose this is c, right? I mean that's how we define this continuous uniform random variable. As we have discussed in the lectures, is that in case of continuous uniform random variable, we don't need to work with the integration. Like if you want, you can work with the integration, that's not an issue. But if let's suppose you want to find out the value of c, since it is very much looking like a rectangle, in fact it is rectangle, and we know that this integration is basically the area of this rectangle, then we can also work with the area. We can also work with the geometry. So what is that area? This is b minus a. This length is b minus a and width is c. So the area is c into b minus a, c into b minus a. You can work with the geometry and that should be 1. So which means c must be 1 upon b minus a. This is one way to find out the c. Another way, as we have discussed, is that integration over a to b of this, or maybe minus infinity to infinity, but since here the PDF is 0, it doesn't matter. After b or before a, the PDF is 0, it doesn't matter. So that's why the integration from a to b, c must be with respect to dx must be 1. And then if you solve for the c, so it will be c into x, and then you put the value of ab. Then if you solve for the c, then again it will be c into b minus a equal to 1, and then c will be again 1 upon b minus a, right? So basically either you do this way or you do this way. So we have also discussed in the lectures that there are two ways. One is using integration, another one is using using the geometry. But we prefer this way, as we know, right? I mean, this is just to recall that what is continuous uniform random variable. Also, intuitively, you need to understand that what is this. See, here we say that it is basically uniform in the sense that if you take any range of same length, which means let's suppose if you take the range, if you take this range, which is let's suppose a to a plus 1, okay, let's suppose you take this range from a to a plus 1, and then you take a plus 1 to a plus 2, you take any range, okay, I mean of the same length basically, then you will say the probability between x being between a to a plus 1 is same as probability of x being between a plus 1 to a plus 2. Basically in this particular area, you take any fragment, you take any length of same length, then the probabilities will be same. That's what this uniform means, right? I hope you are now able to recall that uniform means that the probabilities are same for the same length in this particular region, right? So okay, so I hope that is clear to everyone. I mean you are able to recall, I hope, right? So basically here they have defined two random variables, x and y, right? So let me just go over that. So yeah, so this is the equal probability, and let's just see that what they are saying. They have defined two random variable x and y within the range of 0, 1. So here they have defined within the range of 0, 1. So let me take within the range of 0, 1 two random variables x and y. So since they are same but they are independent, okay, so within the range of 0, 1. Okay, if you want you can write 0 here, or let's just write here only. So now what will the value of this c? What is the value of this c? Since the rectangle area must be 1, so that's why the value of c must be 1 only. Okay, that's great. So that's how this x and y are defined. That's what they are saying. So this is the PDF. PDF means the probability density function, right? Okay. Now they are saying that let's just define a new random variable which is w, which is maximum of x comma y. So w is max of x comma y, and then they are asking some probability about w, that what is the probability that w is less than 1 by 2. Okay, so basically what they are saying the probability of w less than 1 by 2, which is same as saying probability of max of x comma y less than 1 by 2, isn't it? Now it is very interesting. See, if maximum of something is lesser than this value, which is 1 by 2, then don't don't these individually or also have to be less than 1 by 2? Can't you say that probability this maximum is less than 1 by 2? It means that x is less than 1 by 2 and y is also less than 1 by 2, right? If maximum is less than 1 by 2, then x and y both has to be less than 1 by 2, right? So this is the trick that we are playing here. And since they are independent, you can say that probability of x less than 1 by 2 multiplied by probability of y less than 1 by 2, because they are independent. It is given in the question. Just read it out that they are independent uniform random variables. So see, in case of maximum, if they give you that, okay, less than 1 by 2 or less than something, you find out the probability, then you can basically write in this way. Similarly, in case of minimum, if they say probability of, let's suppose they have defined, they ask you the minimum of xy, and then they say 1 by 2, something like this, greater than some number, then it definitely means that they are saying that x must be greater than 1 by 2 and y must be greater than 1 by 2 in case of minimum. In case of minimum, see, if minimum itself is greater than 1 by 2, then both individually has to be greater than 1 by 2. If let's suppose, if let's suppose this is 0.5, right? So let's suppose that this is just 0.01, then how can minimum be greater than 0.5 if one of them is actually less than 0.5? I hope you are able to understand this, right? So just try it out with some values and you will be able to get it. Okay, and if they're independent, most probably it will be given in the question that they're independent, then you can do something like this. So in case of minimum, for greater, you can do, you can work something like this. In case of maximum, for lesser, you can work something like this. But suppose they ask you something opposite, which means they give you the minimum, but they ask you lesser, which means they say the probability, the minimum of x comma y is lesser than 1 by 2. That find out this probability. Then in that case, you can do one thing. You can write it as same as 1 minus probability of minimum of x comma y greater than equal to 1 by 2. Something like this. I mean, just convert this lesser to greater than equal to or greater than. And then you will be able to solve that question. Okay. Anyway, coming back here, they have asked this. And now we just need to find out these two probabilities, that probability that x is less than 1 by 2, right? So what do you think? What is the probability that x is less than 1 by 2? See, this is x and y. This is, let's suppose, 1 by 2. This is suppose 1 by 2, and then what is the probability it is less than 1 by 2, which means they are asking the area of this. Area of this is just 1 by 2, right? Because 1 by 2 into 1, this is just 1 by 2. So what is the probability that x is less than 1 by 2? It is 1 by 2. Similarly, y is less than 1 by 2, it is 1 by 2. That's why it is 1 by 4, right? So 1 by 4 is the answer. So which means 0.25. So let's see the question. So here the answer will be 0.25, right? So that's how you can solve this question. I hope you understood. Very nice question, easy, intuitive. So these kind of questions only GATE ask. They don't ask very tough question from the random variables, in particularly from the distribution of the random variable, particularly from the continuous case. In fact, they have asked very less number of questions in case of contiguous. If they ask you, then they will be asking you easy question most probably, and this is one of the most trickiest question that we can have as per the GATE level. Okay, thank you so much. Thanks for watching.